Hi everyone. Today I'm going to talk about AI, machine learning, deep learning theories, applications, and how to deploy and serve them in Huawei Cloud. I am currently working as a machine learning or AI engineer at Huawei. So let's get started. What is the table of contents? First, I'm going to talk about what is artificial intelligence, and after that, I'm going to talk about pros and cons of using AI in daily life, meaning advantages and disadvantages. Then, I'm going to talk about some use cases and real life applications of AI. After that, I'm going to talk about AI subfields. Then I will mention the definitions, usage areas, and real-life applications of AI subfields. After that, I will mention what is Huawei Cloud, model arts, and code arts. Then I will do some little practical session about deploying and serving a person detection application in Huawei Cloud. So, what is artificial intelligence? Artificial intelligence is a technology which enables machines and computers to simulate several human intelligence processes and actions, such as learning, problem solving, comprehension, decision making, creativity, and autonomy. AI can perform many actions, such as observing objects and humans, analyzing data, making recommendations, understanding and translating both spoken and written language, and so on. What are the advantages or pros of using AI in daily life? AI brings reduced human errors, faster decision making, and save time. Also, AI brings unbiased decisions. Moreover, when we use AI, we can enhance the efficiency and productivity of our daily jobs and maybe the jobs of the businesses. Also, AI brings enhanced safety to both our daily lives and to the businesses. Also, AI brings better customer experience, quicker and more accurate decision making, and reduce risks. Moreover, AI brings more availability because AI products are almost always available 7 days and 24 hours, and they are more available than humans. Also, AI brings enhanced surveillance, which is good for security. Also, AI brings better personalization of user experiences, which is good for users. Moreover, AI brings reduced costs and better resource management. Also, AI brings improved financial management with the management of financial resources like stocks. What are the cons or disadvantages of using AI in daily life? There might be some ethical problems. Also, AI solutions are very costly to implement because they require high resources. Also, AI potentially reduce the human jobs such as cashiers and customer service agents. AI reduce critical thinking abilities for humans to perform tasks. Also, lack of creativity and emotions is one of the con of using AI. For example, when we use ChatGPT, we shouldn't give the company data, and because it might lead to some security problems, and it is bad for us and for company as well. What are some real life use cases and applications of AI? Virtual voice based assistants such as Siri and Alexa, fraud detection in financial institutions, image and facial recognition in security systems, personalized recommendation systems used in e commerce platforms like Amazon Personalized or streaming platforms like Netflix recommendation engine. Also, in the medical field, AI takes place. Medical healthcare and diagnosis systems like IBM Watson Health is one of the use cases and applications of AI. Real-time comprehension and translation systems for both spoken and written language, like Google Translate, is another application. Large language models generating human-like text responses beneficial in various areas such as education, coding, customer support, content creation, and so on. and examples to LLMs are such as OpenAI's ChatGPT. Self-driving cars is another example of AI application. Natural disaster prediction is another one, and resume screening in human resources departments is the last example that I will give. Resume screening automation is achieved by AI, and this eases the job of human resources departments and fastens the job hirings as well. What are some AI soft fields? Machine learning, deep learning, image processing or recognition, and computer vision, speech recognition, text to speech, speech to text conversions, and natural language processing is another subfield. Also, search, which includes depth first search, breadth first search, and A star, and so on, is another subfield. Robotics is another subfield of AI, and there are many more subfields that I have not listed in this slide of AI. What is machine learning? Machine learning is the ability of machines and computers to learn certain types of tasks and gradually improve their performance on a task through experience with or without a labeled data by recognizing patterns and making predictions or decisions based on data. What are the types of machine learning? Unsupervised learning, supervised learning, semi-supervised learning, and reinforcement learning are the machine learning types. As you can see, this image lists some real-life applications of each machine learning type. For example, housing price prediction is supervised learning, customer segmentation unsupervised learning, text classification is semi-supervised, and optimized marketing is reinforcement learning. So let's move on. What is supervised learning? Learning patterns, behaviors, relationships, and anomalies in data by training models on labeled input data. What are some example algorithms to supervised learning? Classification and regression, decision tree classification, KNN classification, support vector machine classification, linear regression, naive-based classification are some examples to supervised learning algorithms. What are some real-life applications? Stock price prediction, sentiment analysis on tweets, disease diagnosis, ad revenue prediction, credit card fraud detection, and employee churn prediction are some real-life application examples to supervised learning. So let's move on. What is unsupervised learning? It is a type of machine learning where the model learns from unlabeled data by identifying groupings, distribution patterns, behaviors, and relationships in the data. It does this by using distance metrics among the data points such as Euclidean and Manhattan, and similarity measures like Yakkard similarity. Example algorithms are clustering and dimensionality reduction, such as examples to clustering, we can give k-means, and as examples to dimensionality reduction, we can give principal component analysis. As more examples to clustering, we can give hierarchical clustering, spectral clustering, and so on. What are some real-life applications of unsupervised learning? Customer group clustering and document clustering are some real-life applications. So let's move on. Semi-supervised learning, it is learning from half-labeled input data. Email spam classification can be given as a real-life example, as the users can report some of the emails as spam and the others as normal. Here, manual labeling with user feedbacks is in the place. Medical image classification can also be given as another real-life example. This semi-supervised learning type is more suitable to real life than supervised learning, as there is a vast amount of data to be labeled to solve machine learning based problems within each sector, which is very time consuming and costly to deal with. As this bullet point said, there are a lot of data to label and a lot of data is needed to make a machine learn that task. So it is good to use semi-supervised learning and make the model learn from half-labeled input data. and email spam classification and medical image classification are some of these examples. Some of the examples to the real life applications of semi-supervised learning. So let's move on. What is reinforcement learning? It is learning dynamically from feedbacks obtained from the environment by the agent. The primary goal is to maximize the total reward obtained. What are some real life applications? Autonomous navigation, self-driving cars, AI in games such as chess and Go, stock trading bots, and so on. And you can see the interaction of agent and environment in a typical reinforcement learning model. Agent does an action and stimulates the environment, and then agent receives a reward and subsequent state from the environment, and and this receiving affects the agent. So let's move on. What is deep learning? Deep learning is an AI subfield focusing on the usage of neural networks to perform tasks such as classification, regression, representation, learning, and so on. It takes its inspiration from biological neuroscience and is based on gathering artificial neurons into respective layers and training them to process data and learn. In deep learning term, deep stands for the usage of multiple layers in the network. You can see a deep learning architecture in this image. There are input node layers, hidden layers, and output node layers, and there are multiple input node layers, multiple hidden layers, and multiple output layers, which makes it a deep neural network. What are some real life use cases and applications of deep learning? Information retrieval from unstructured documents with deep learning based information extraction models such as VBERT and BiLSTM CRF is one of the applications. Cancer cell detection to understand medical images and help doctors by identifying cancer cells is another application. Autonomous vehicles to handle different situations in traffic, such as detection of traffic lights, recognition of roads and signs, avoiding pedestrians, and so on, is another application, which is self-driving in overall. What are image processing and recognition? Image processing is a field of artificial intelligence focusing on the manipulation, analysis, and transformation of images to extract meaningful information, improve visual quality, and prepare the image for further tasks. It involves the application of mathematical and computational techniques to images to improve their quality, detect the defects and patterns in these images, or analyze specific regions or content. What is image recognition? It's a field of artificial intelligence focusing on the interpretation of or identification of objects, patterns, people, and other entities within an image. The main goal is to understand and classify the content in the image through the usage of machine learning and deep learning algorithms. What is computer vision? Computer vision is a field of artificial intelligence enabling computers to identify and understand objects, people, and other meaningful information in several data types such as video, image, animation, and so on. And it does this by using machine learning and deep learning algorithms. What are some real-life applications and use cases of computer vision? Navigation in self-driving cars, such as Tesla's autopilot, facial recognition systems for attendance tracking and access control, like Face ID on smartphones, diagnosis of diseases, detecting anomaly like tumors from retinal images, and image-based product search and recommendation tools like Amazon's Style Snap. I can send the slide that I have prepared after this session, and you can check the Amazon's style snap from this link. So let's move on. What is speech recognition, TTS, and STT conversions? Speech recognition is the process of converting spoken language into machine learning and into text using machine learning and deep learning algorithms. It enables computers to identify and process human speech. As Siri and Alexa can be given as real-life applications of speech recognition. Speech to text is basically converting this to the speech to the text in real time. Subtitle generation in movies is a typical example of STT conversion. TTS is the vice versa of STT, and it is an application focusing on converting the text to the speech in real time. And book reading technologies can be given as a typical example to TTS conversion. And you can see the sample working architectures of TTS and STT conversions. Input text comes here, and then text analysis takes place here, and some phonetic analysis and grammar analysis takes place here, and then the received data goes to the speech database. Then some waves come into place. After that, as a final output, synthesized speech is obtained. And in this model, the hello world sound is converted to the hello world text with the help of acoustic models and language models. And at the beginning, the features are extracted from the sound, and it is fed to the acoustic model. So let's move on. What is natural language processing? It's a field of AI focusing on enabling computers and machines to identify, process, interpret, and respond to the human language in a meaningful way. And this shows some steps of a typical NLP pipeline. There is text input collection, and then text pre-processing, text representation, and features are extracted from text, and they are selected based on our task. And then model selection and training, depending on our specific task, comes in the fifth place. Then we might deploy and run inference on the trained model. Also, there might be some additional optimization and maintenance operations after deploying the model. So let's move on. What are some applications and use cases of NLP? Chatbots for customer support, translation services such as Google Translate, voice-based virtual assistants such as Siri and Amazon Alexa, sentiment analysis on tweets and customer reviews, search engines like Google Search, email spam detection and filtering, article content categorization, information extraction from important documents with techniques like named entity recognition, text generation tools like OpenAI's GPT models, and so on. So let's move on. What is search in AI? Search is the process of an agent navigating from a starting state to a goal state by transitioning through intermediate states. There are different types of search algorithms such as depth first, breadth first, A star, and so on. Search algorithms typically is divided into two categories, which is uninformed search and informed search. Uninformed search is divided typically into three categories, which is depth first, breadth first, and uniform cost search. And informed search is typically divided into three categories, which is greedy search, A-star search, and graph search. Informed search is basically informed from the heuristics, and it is more suitable compared to the uninformed search, depending on the tasks, because it is the job of agent to pick which way the agents will go in the steps of search. So you can check the search algorithms in AI from this link after I sent the presentation from after this session. What are some real-life applications of search? Pathfinding in navigation systems, robotics and autonomous vehicles, and game AI in games like checkers or chess are some real-life applications of search. So let's move on. What is robotics? Robotics is a field of AI enabling robots to perceive, reason, act, and respond intelligently like people with almost no intervention in dynamic environments. What are some real life applications of robotics? Robots for service in restaurants and cafes, for delivery of meals, removing weeds, harvesting crops, space exploration, and so on are some real life applications. And you can check some real life applications of robotics from the link I provided below. So, what is Huawei Cloud? Uh, we develop an AI application, for example, but we generally develop it in our local computer, and we need some more resource requirements and an environment that can handle such big resource intensity in the AI applications. As I said, AI applications require a lot of resources. So we need a cloud-like environment, and I will introduce Huawei Cloud now. Huawei Cloud is a cloud platform offered by Huawei Technologies, which supports digital transformation of businesses by providing platform infrastructure and software services, and aims to provide users with a fast, reliable, affordable, and flexible cloud experience. Huawei Cloud provides several services for different purposes, such as computation, storage, networking, database, AI algorithms like OCR, security, big data analytics, and so on. By the way, OCR stands for optical character recognition. So let's move on. What is Model Arts? Model Arts is basically a Huawei cloud service and one-stop AI development platform enabling to build, train, and deploy machine learning models quickly and easily and manage full lifecycle AI workflows. Model Arts speeds up the AI development with important capabilities, including data pre-processing, auto-labeling, distributed training, automated model design and building, and one-click workflow execution. This automation is provided by a code-free tool named XML in Modelars, allowing users to execute AI development workflows without requiring any coding. Modelars supports popular open-source AI development frameworks such as TensorFlow, PyTorch, and MindSpore. It also allows us to use customized algorithm frameworks adjusted according to the specific needs. This brings an additional flexibility to the modelers as the customization of frameworks is allowed. So you can see the sample execution architecture, sample working architecture of modelers here. And the right one is the execution flow of XML tool, which is code free. You can check the model arts to get more info from the link I provided here. So let's move on. What is CodeArts? CodeArts is a cloud-based and one-stop platform in Huawei Cloud, providing services for requirement delivery, code commit, check, build, verification, deployment, and release throughout the entire software lifecycle. It supports continuous integration and development of AI or machine learning applications and comprehensively manage the full software development workflows of them, including MLOps processes. CODAS is good for the MLOps processes of the AI applications, and this is good for managing the versions and the code of the AI applications. You can check this link for getting more information about CodeArts. So let's move on. So let's do a practical session of serving a person detection application in Huawei Cloud. I have downloaded the dataset for this application, which is person detection with XML annotations. And I have created a subset from this dataset. So let's finish the downloading. Okay, let's look to the data. The data is divided into three subfolders, which is test, trained, validation, which are for testing, training, and validation respectively. And let's look at the test subfolder. There are JPEG images in the test subfolder and in the other subfolders as well. And let's see a sample JPEG image. This is a person photo with within different kind of situations, and let's look at the annotation of the first image that I have shown to you. This one. This is an XML annotation of the picture that I have just shown to you. And this includes the bounding box coordinates, which are xmin, ymin, xmax, and ymax. And this constitutes the bounding box rectangle of the person that is to be detected. And the other annotations and images are like this one. So I have created a subset of this data set, which is, let me find this one. There are 50 JPEG images and 50 XML annotations of them in this folder, which constitutes 100 items in total. So let's open Huawei Cloud. This is the modular tool that I have mentioned in my presentation. You can label data and train AI models with just one click in an automated manner, or you can do it manually. You can do the automated one in XML and manual processing in these parts, which is label data, training jobs, and model deployment. So there's we generally keep data in a service of Huawei Cloud called Object Bucket Service, and let me show the Object Bucket Service as well. Object Storage Service. Here is the object storage service, and we can create buckets in that service to store the data that we want. I have created a person detection bucket here to store my data, and we can interact with the object storage service via several APIs and software development kits, and also a desktop application called OBS Browser. I have used OBS Browser to interact with Object Storage Service, so let me go out from SPAS, which is proxy. So this is OBS Browser application. that with which we can interact with OBS buckets. Let me enter my password. So we are in the bucket manipulation place. I have created a person detect bucket for storing my data. So let's create a bucket from scratch here. Let's make the region is Shanghai. Let's make the bucket name person detection demo. So as you can see, person detection demo is created here. So let me change the let me change the region to Singapore as it is more available. Let me recreate AP Singapore, and the bucket name is person detection demo. Okay. I didn't say that. So let me close this. Let me recreate person detection demo. Why does it say so? Let me show it from the one that I have already done, because the training might consume the budget. But I can show from scratch if I can figure out what's going on. So this is model arts. We can label data from here, and we for that we should create labeling jobs. And we can create data from this part. And we can name our data such as person detection demo data, and we can write the description of data. This is a person detection demo data. And the various types of data is supported, such as image, audio, text, video, and free format and table. But we're gonna use image and for our person detection task. And we can select the input OBS path of our data from here. This is person detection bucket and person detection data. Okay, labeled. Uh, we label it according to the Pascal VOC architecture, the Pascal VOC format, which is JPEG XML pairs, and the output dataset path is specified here. We can select output paths, and then we should submit. We should wait for data to be published. So demo data is uploaded. We can label this data from label data parts. So we should create a labeling job, but where labeling? Oh, we can create from the labeling part of the dataset. So we can name it person detection labeling job demo. This is a labeling job demonstration for the person detection task can be entered, and we can select the labeling type here. Since we do an object detection task, we select object detection, and as the data set, we should create select the person detection demo data that we have just created, and we can create here. So let's wait. So our data is labeled successfully. As you remember, we have 50 JPEG images and 50 XML annotations of them. So we can execute the XML flow, which constitute the typical machine learning pipeline steps, which are labeling, pre-processing, training, and deployment. So we should create an object detection task, object detection project. So we can name it person detection project. So as a description, we can say this is an XML flow, XML machine learning flow for a person detection task. And as the data set, we should select the one that we have created, which is demo data, person detection. And as the output, we can select the folder, which is person detection output. And this basically stores the person detection outputs. And I can show how to create a folder within a bucket name. We should press create folder, and we can name the folder whichever name we want. So we can say maybe detection output, or just to be more specific, person detection demo output. And it will be created, folder created successfully. Maybe we can select the one that we just created for output path. We we choose the training flavor here. So we created the project. This is typical XML flow. I will stop at some point in this workflow because it takes unnecessarily much time, and I will show the final output of this workflow. So let's wait for some time. Let's do next. Here, data validation is being done in this step. So it does this. Let me show the final output of the properly executed one. This is the proper execution, and you can see the metrics like precision recall here in the evaluation report. And this is the data validation part. And basically, without coding, you can automate the machine learning flows by using the XML under the modularized service of Huawei Cloud. So I want to actually redo this again. Say person demo. Multi-availability zone is basically the availability of bucket from the multiple zones. Person demo, let's say. Okay, so under person demo, it might take some time for due to network connection. So we can upload data to OBS bucket by pressing upload. We can upload either as files or as a folder containing files. So let's create a output folder. This is for storing data. Actually, we can upload the data as a full folder rather than files, which is easier. So let's upload it as full folder. Desktop. Our data is here. Let's check. Okay. In the task management part, the files in this folder are uploaded one by one in a queue, and when the upload operation is completed, it moves the specific file to the completed section, or when there is any fails, it moves the file to the failed section, and so on. So let's finish the uploading operation. So the uploading operation is successfully completed. Let's go to our Huawei Cloud console. Let's delete this. And let's first create the data set that we have just created. Person demo dataset. I will skip the description as I have mentioned. Person demo and person detection data. Okay. Labeled JPEG XML pairs as I mentioned. And let's select the output data path. Person demo, person output. Okay, submit. Dataset is being uploaded now. Okay, dataset is uploaded. Let's label. Actually, we can auto label with XML. Let's create object detection project. Person detection demo demonstration dataset. The person demo dataset. Let me check. Person demo dataset. Okay, let's create object detection project. Person detection demonstration. Person demo dataset. Let's select the output OBS path. Person demo. Person output. Okay. Now let's select the training mode. Let's wait for some time. Now the data is validated. Now this is in pending mode. You can check instance details and specific steps in this execution from instance details. Oh, it is running. Let's check instance details. As I said, this will take a lot of time. So I can stop when this step is finished. This step is finished successfully actually. Uh, at this step, the model will be trained and and deployed. So let's maybe wait. No, I mean, this is a pending mode. I mean, this will take how much time actually, and I have shown the fully working flow. I can. No, it's running. So let's wait then. Just two steps. Refresh. Let's check these details. As you can see, a PyTorch model on Ubuntu uh, is running, and Python 3.7 is used, and PyTorch 1.8.0 is used as the version. As I said, this would take much time. So, and I also show you to the fully working pipeline, and this will work actually because data is validated successfully. So I can show an abnormal example of why data being not this one, but I might delete it. No, anyway, let's delete. I can show you the deployed services. Uh, I have deployed the service of person detection here, uh, and it shows the deployment steps here. Uh, the environment is prepared and the images start to be built, and finally it is deployed. Uh, Maybe we can check the pipeline working now. It is again running. can wait this a little bit. Let's check instance details. Anyway, this will take more time. Actually, maybe it might be related to the network